All right, guys, so what we're doing today is we are starting Chapter 5. Today will be the first day of Chapter 5, and Chapter 5 is going to completely revolve around triangles. So we're going to be learning about triangles. Now, triangles will come up again and again. Triangles are very important throughout geometry. They are used in a lot of different places. Now, the first thing we're going to do is talk about classifying triangles by their sides and angles. Now, based off of the vocab sheet that you guys did yesterday, we would classify a scalene triangle by what? What makes it a scalene triangle? There's no congruent sides. If the triangle is scalene, it has no congruent sides. If it's an isosceles triangle, it has at least two congruent sides. An equilateral would be all congruent sides, three congruent sides. If no sides are congruent, it is considered to be scalene. If two sides are congruent, it's isosceles. And if three sides are congruent, it is equilateral. Equilateral. That'll be dealing with isosceles triangles. Now, if a triangle is acute, it has what? Three angles that are acute, or three angles that are less than 90 degrees. If it's a right triangle, it has what? An obtuse triangle would have? One obtuse angle, because it's going to be an obtuse triangle, so it needs one angle that is the least obtuse. And an equiangular triangle will have three congruent angles. Equilateral and equiangular, yes. Because if we have one, we have to have the other. Any questions on this here? All right. We want to talk about first, we're talking about classifying angles. We're classifying triangles by its angles and side lengths. Now, it might be a little bit hard to tell, but in the diagram here, we do have a triangle. And it gave us two markers on either one of these sides. Well, those two markers are saying that those two sides are what? Congruent, they're equal. Well, the other side doesn't have it, so would it be congruent or equal to those other two? So how many sides in the triangle, are congruent? So what does that make it? It makes an isosceles triangle. Now, if we measured them, these two angles down here would both be 55 degrees, and this top angle would be 70 degrees. Because those would add together to be 180. But how can we define the triangle given these angles? Since all the angles are less than 90, then it would be acute. So how can we name this triangle based off sides and angles? It is what? Acute. An isosceles acute triangle. We could say an acute isosceles triangle, but we're naming it based off both the sides and angles. And that's it. Questions on this here? So let's look at the next one. We don't even need that. Looking at this triangle here, what can we name it? It does have a right angle, yes? So that means it's a what? So it is going to be a right triangle. Because it's going to be right, because it has a right angle. Are any of the side lengths the same? No, we're not told any of them are the same, so it has to be what? So it's a right scalene triangle. It is a right scalene triangle because it has a right angle and none of the sides are the same, so it is a right scalene triangle.
Okay, so do we have to do the obtuse?
Because if it's an obtuse triangle, it has what? One obtuse angle. Since this has one acute or one right angle, it is a right triangle. Questions on this here? So let's look at this one here, the next one, number one, triangle number one. We're given side lengths A, B, and C. And we have a right angle marker. So what can we name it based off the sides and angles? Scalene, right triangle. Right scalene would work as well. I know someone did say right scalene, and that is the correct answer. Both of those are the correct answer. Because the way we name it based off the angles is, it's a right triangle, so it would be right. The sides are not the same, so it would be scalene. So it's a right scalene triangle, or it's a scalene right triangle. Those are the same things. How about the next one? I would agree. Because one side length is A, one side length is B, and one side length is C. So those are all different lengths. Now, we would need to know a little bit more, because most likely this angle up here would be the obtuse angle, but it would be nice to know a little bit more than that. Right, but for this here, we'll go on and just say obtuse. Scalene obtuse. So this one here, we can still say it is. Yes, it is isosceles. S-E-L-E-S. Because we know two of the side lengths are both B. They're the same measure. Questions on this here? So let's look at the next one. So that might answer your question. So if we look at this here, what can we say for certain? Equilateral. Lateral. Equilateral. Because all three side lengths are the same. It would be acute. Equiangular? Yes. I will take acute, but it is also equiangular. Acute means that all three angles are less than 90. Equiangular, all three angles are the same. And we'll go over the exact property of why this works, but these two, if we do have equilateral, it is going to be equiangular.
So if
But
you just put one of them, would it be counterclockwise?
I will take acute instead of equiangular, But equilateral, that's the only one we have. Because it's told us all three sides are the same, it has to be equilateral. We'll eventually go over the exact property of why these two connect, but these two do connect to each other. If we have one, we will have the other. So if we do know all three angles are the same, all three sides have to be the same. And if all three sides are the same, all three angles have to be. And we'll get into more detail exactly why once we delve more into this chapter. Now the next one. Isosceles. Acute triangle. Because we do have two sides that are the same, so it would be isosceles. And since it does seem that all angles are less than 90, it would be acute. And the last one. Isosceles right triangle. Any questions on any of this here? You ready for the next thing? Because I feel like y'all feel comfortable with naming them isosceles right, isosceles scalene or equilateral, acute right, obtuse, or equiangular. So the next thing we want to do is we want to classify triangle OPQ by its sides, then determine if it is a right triangle. Well, to be able to name it or classify it by its sides as scalene, isosceles, or equilateral, we need to know the sides what? Length. Because if we know what the lengths are, then we can see if 1, 2, or well, none, 2, or 3 are the same. Well, we're going to be using the distance formula. We're going to be using the distance formula. X2 minus x1 squared plus y2 minus y1 squared. Really, x1, x2, we're subtracting the x values. The two x values go together, the two y values go together. So, again, when we're using this formula, we really want the x values together and the y values together. That's the main thing when we plug it in. Parentheses. So distance formula, we'll find the distance from P to Q first. What are the x values for the points P and Q? So -1, 6 and -1, yes? Because here, P's x value is -1. Q's x value is 6. So on the first one, we can, 6 minus -1. Or we can say -1 minus 6. Either one will give us the same value when we square it. The two y values are 3 and 2. So in the other one, we'll have 3 minus 2 squared. The order of which x value we put first or which y value we put first does not matter. We need the x's in the same set of parentheses, the y's in the same set of parentheses. Now at this point here, we could just plug this into the calculator. We can do square root, parentheses, 6 minus -1, close parentheses, squared, plus open parentheses, 3 minus 2, close parentheses, squared, enter, and it will tell you the answer. Yeah, square root of 50. Because if we do this by hand, 6 minus -1, well, negative and negative make a. So 6 plus 1 would be 7. 3 minus 2 is 1. Well, 7 squared, 7 times 7 is 1 squared is, which would be the square root of. Now this here would reduce to 5 square root of 2. Because square root of 50 is fine, 5 square root of 2 is fine. Because if you typed it into the yellow calculator, it would tell you it's 5 square root of 2. So the distance from P to Q is 5 square root of 2. Questions on this here? So we know one of the 3 sides, yes? Well, we're going to have to do this 2 more times because we need the distance for all 3 sides. Questions on this here? So the next one we can go from is P to O. Well, our x values for P and O are -1 and. So we can say -1 minus 0 or 0 minus -1. Our y values. Now at this point here, again, we could just type this straight into the yellow calculator, hit enter, and it would give us the answer. If we did this by hand, well, -1 minus 0 is 2 minus 0 is, well, -1 squared is 2 squared is, and 1 plus 4 is, well, the square root of 5 will not simplify. That's as simplified as it gets. So what are we missing now? The distance from O to Q. We good with this here before we move on to the next one? Questions? Okay. Let's look at the next one, guys. Sadie. So again, we need to do the distance formula 1 more time to get the last length. So we're going from O to Q. Now the x values, so we'd have 6 minus 0 squared plus 3 minus 0 squared. Now again, the order in which we plug the x's and the y's doesn't really matter as long as the x's are in the same set of parentheses and the y's are as well. Now if we did this by hand, well, 6 minus 0 is, 3 minus 0 is, 6 times 6 is 36, 9 times 9 is, so this, now this will work out to be 3 square root of 5 if we do reduce it. So using the distance formula 3 times, we do get the 3 side lengths. What can we say about the 3 side lengths? So that means, what kind of triangle is this? It is scalene because we have 3 different side lengths. Is that all it was asking for? Then what? Then determine if it is a right triangle. Yes, sir. Yes. Where is, if it had a right angle, where would it be? Oh. At point O. If it had a right angle, it would be at point O, yes? If that is a right angle, what does it mean those 2 side lengths are? They're 90 degrees. What kind of lines intersect at 90 degrees? Perpendicular lines. Those 2 lines are perpendicular if their slopes are opposite reciprocals. If we can if we can change them and flip them, or their product is -1. So if I find the slopes of PO and QO, and they're the opposite reciprocals, then it is a right angle. They intersect at a right angle because they are perpendicular. So the last thing we need to do for this is find the slope of PO and OQ. So for PO, we need the y values first. And the y values at P is? And the y value at O is 0. So we can say 2 minus 0. What is the x value at P? And the y value at O is 0. 2 minus 0 is? -1 minus 0. 2 divided by -1 is? -2. -2 over 1. So if we want these two lines to be perpendicular, we're wanting the other one to be the opposite reciprocal. Yes? So we need to change the sign and flip it. So since it's negative, it becomes positive, and it would exactly be 1 over 2 or +1/2. So if the other slope is +1/2, it means these two lines are perpendicular, and it is a right triangle. So let's find the other slope. Well, the y value for Q is? The y value for O is? The x value for Q is? And the y value is? Or x value of O is 0. 3 minus 0 is? 6 minus 0. So this would be a scalene, right? Now again, another way we can check is if we take -2 and multiply it by 1/2. And if the product of their slopes is -1, then the two lines are perpendicular. If we do this here, that would be -2 over 2, which is -1. So the lines are perpendicular to each other. So this would be a right triangle. Questions on this here before we look at the next one? Yes, sir. Yes. I do. But really for most of this here, all the distance formulas that we used, did we have to really do them by hand? No, because we could have plugged all that into the calculator and got the answer right out. We don't have to do it by hand. Yeah, you could have plugged these into the calculator for the distance. Let's look at this one here. When we look at this here, so again, to classify the triangle by its sides, then determine whether it's a right triangle. So we have A at 0, 0, B at 3, 3, and C is at -3, 3. Now, here, we do already have one of the links from C to B is along a straight axis, yes? Well, I can count over 1, 2, 3, 4, 5. Because we can count the axis straight across. Now, if we wanted to, we could use the distance formula. Because distance is equal to the square root. So our two x values would be -3 minus squared, plus the two y values would be 3 minus 3 squared, because -3 and 3 are the x, 3 and 3 are the y's. So we can plug them in and solve. Now at this point here, again, y'all could type this straight into the calculator just as we see it here, and it would give us the answer. Well, 3 minus 3 is negative 6. Now, 3 minus 3 here, this would be 0. Now, negative 6 squared is, and the square root of 36 is. So the distance from C to B is 6. From where to where? From A to C or B to A? Okay. Are we ready to move on to B to A? Okay. So let's look from B to A. So our distance formula would be the square root. Our x value at B is minus squared plus minus 0. So we would have 3 squared plus 9 plus 9 would be the square root of 18. Now, if we had typed this into a calculator, it would tell us that it's 2 square root, or 3 square root of 2. Because square root of 18 would be 3 square root of 2. If it was 36, then it would be 6. Because square root of 36 is 6. Any questions on how we found the distance from B to A? Now we need to find the distance from C to A, because we need to find the last distance. Now our x values for C and A are negative 3 minus 0 squared. The y values would be 3 and negative 3 minus 0 is 3 minus 0 is, what is negative 3 squared? 3 squared is, and 9 plus 9 is the, which would reduce to 3 square root of 2. So what can we classify this triangle based off its sides? It would be isosceles because we have two sides that are the same. Any questions on this here before we determine whether or not it is a right triangle? So if it is a right triangle, most likely where's our right angle going to be? At this one here. Because most likely that's where the right angle is going to occur. So we can find the slope from C to A and the slope from B to A. So at points C and A, what are our y values? Are 3 minus 0. The x values are negative 3 minus 0. Well, 3 minus 0 is, negative 3 minus 0 is, 3 divided by negative 3 is negative 1, because 3 divided by 3 would be 1, and since the denominator is negative and the numerator is positive, the whole number would be negative. Questions on this here? Now, if we're wanting the slopes to be perpendicular, it's the opposite reciprocal. Since the one slope is negative, the other is going to be positive. And if we flip it, well, 1 flipped would be 1 over, keep dropping, 1, and 1 divided by 1 is? So if these are going to have opposite reciprocal slopes, the other slope must be positive 1. So from B to A. So minus 3 minus 0 is? 3 minus 0 is? So it's an isosceles right. And that's it. Mhm. Any other questions on any of this here? Do we feel good with these here? Okay. Do you need to see another example of one of these? Okay. So that is all we are going to do today. Your homework is on page 212, problems 3 through 10.